Hello and welcome to Tech of the Day. Today we are going to talk about develop for code scalability. This topic is really interesting because it includes implementing autoscaling, implement code that address singleton instances, and implement code that handles transient faults. This sounds a little bit not familiar, maybe, but this is really interesting thing because developing solutions in Azure that are scalable is really important, and scalability is one of the main thing in Azure, and we should take advantage of that. So let's get started. Topics we have already talked about. We will talk about implementing auto scaling, implement code that addresses singleton instances, implement code that handles transient faults. So let's go. Implement autoscale. In this lesson, we will cover autoscale patterns, autoscale setting schema, and best practices for autoscaling. So autoscale is built-in feature of Azure Cloud Services, mobile services, virtual machines, and websites that help applications perform their best when demand changes. Of course, performance means different things for different applications. Some apps are CPU bound, other memory bound. For example, you could have a web app that handles millions of requests during the day and none at night. So at Autoscale can scale your service by any of these or by custom metric you define. So Autoscale is a built-in feature of Azure Cloud Services, mobile services, virtual machines, and websites. Its primary advantage of cloud is elastic scaling, the ability to use as much capacity as you need. So what is scaling out as load increase, scaling in when extra capacity is not needed. So that is auto scaling. Many Microsoft Azure services provide the capability to scale both manually and automatically. You can define some rules and it can be automatic. Autoscale refers to the capability of many of these services to monitor the application instances and automatically scale appropriately to handle the current usage of the application. So using autoscale, your cloud service can scale out and in to exactly match the amount of instances needed for your specific computing pattern. So autoscale metrics. Azure Monitor autoscaling allows you to scale the number of running instances up or down based on telemetry data metrics. By default, resource manager based virtual machines and virtual machines skill sets emit basic host level metrics. In addition, when you configure diagnostics data collection for an Azure virtual machine and virtual machine skill sets, the Azure Diagnostic extension also emit guest OS performance counters, commonly known as guest OS metrics. You use all these metrics in autoscale rules. So you can use these rules to autoscale. You can also perform autoscale based on common web server metrics such as HttpQueueLength. Its metric name is HttpQueueLength. This table lists available servers from web apps metrics. So here we have all the um, all the things from web app metric. You can scale by storage queue length, which is the number of messages in storage queue. Storage queue length is special metric and threshold is number of messages per instance. For example, if there are two instances and if the threshold is set to 100, scaling occurs when the total number of messages in the queue is 200. That can be 100 messages per instance. 120 and 80 or any other combination that adds up to 100, 200 or more. So the total should be 200. You can scale by service bus queue length, which is the number of messages in the service bus queue. And service bus length is a special metric, and threshold is number of messages per instance. For example, if there are two instances and the threshold is set to 100, scaling occurs when the total number of messages in the queue is 200. That can be 100 per instance. 120 and 80 or any other combination that's adds up to 200. So and the scaling auto scaling metric, you can have CPU by CPU percentage, memory percentage, data in, data out, HttpQ, disk queue. So CPU percentage means the average amount of CPU time used across all instances of the plan. Memory percentage used, data in, so the average incoming bandwidth used across all instances of the plan. Data out, same way, if the average outgoing bandwidth used across all instances of the plan. HttpQ, the average number of HTTP requests that had to sit in the queue before being fulfilled. A high or increasing HttpQueueLength is a symptom of a plan under heavy load, so you can decide depending on the requests. Autoscale patterns. So Azure Monitor Autoscale applies only to virtual machine skill sets and cloud services, app services, web apps, and API management services. So autoscale patterns are scale based on CPU, scale differently on weekends versus weekdays, scale differently during holidays, scale based on custom metrics. As by name, it's clear. This is skill based on CPU, means on CPU performance, like in the previous one we saw CPU percentage used, and scale differently on weekdays and weekends, because on weekends you might have heavy load on e-commerce websites, so you can have it more you can scale out. Scale differently during holidays, you might have heavy load or you might have not at all load, depending on the type of website or type of application. Scale based on custom metrics, you can have totally different scenarios. So for that, scale based on CPU. So when you have a scale based on CPU, you can set a specific rule. So you have a web app, virtual machine skill sets, cloud service app, and you want to scale out, scale in based on CPU. Additionally, you want to ensure there is a minimum number of instances. So also you want to ensure that you set a maximum limit to the number of instances you can scale to. So these type of things you can. So you see, when this virtual machine skill set is CPU percentage less than 75%, then increase instance by something, and same way decrease instance if it's less than 25%. Scale differently on weekdays and weekends. So you see here, you can scale depending on the repeat every day. So you can only repeat it on Saturday, Sunday, depending. Maybe you can have some other specific days. So instead of weekend, you can say Tuesday, Wednesday, I want to scale out, I want to increase specific amount of instances. Like here we are increasing 3. Same way, I can increase it during holidays. So when holiday spike as ASP, I named it holiday spike ASP, and increase the count by 2. And when holiday spike CPU percentage is less than 30, decrease the instance count by 1. And I have minimum instance limit is 2, maximum is 5, default is 2. So default will be always 2, and it can increase up to 5 instances. Scale based on custom metrics, I can add my own rules. So I can create my own rules. That means custom metric loan divided by loan some submissions is greater than 100, then increase by. So I can create my own rules. Autoscale setting schema. As you can see, autoscale settings help ensure that you have the right amount of resources running to handle the fluctuating load of your application. You can configure autoscale settings to be triggered based on metrics that indicate load or performance, or triggered at the scheduled date and time. So here you see one profile in the example, and you see an array of profiles and an array of rules. So you see one profile, main profile, and then you see array of rules. This is inside the area of profiles, and in the profile you have an array of rules. So by defining these rules, you can auto scale. So this is like your auto scale settings schema. Auto scale settings schema, scale out rules. So here we have an example, the auto scale settings schema. This autoscale setting has two metric rule in this profile, one for scale out and one for scale in. The scale out rule is triggered when the virtual machine scale sets average percentage CPU metric is greater than 85% for the past 10 minutes. So you see here percentage CPU, metric name, and metric resource URI, time gain, then a statistic average, time window for 10 minutes, time aggregation average, operator greater than, threshold 85. And when it's greater than that, then scale out. Same way, scale action increase. So once you have the rule, then you need to define the scale action. So increase, type change count value 1 and cool down for 5 minutes. So you're setting up, you're increasing the scale out rule. The same way we can have auto scale settings schema scale in rule. So here we say average for 10 minutes. If it's less than 60, then we decrease the count by 1, and then we cool down period is 5 minutes. Fixed date profile. So further for scale out scale in, after that you can, this profile is for special cases. For example, let's say you have an important event coming up on December 26th. You want the minimum and maximum capacity of your resources to be different on that day, but still scale on the same metrics. In this case, you should add a fixed date profile to your settings list of profiles. The profile is configured to run only on events day. For any another day, Autoscale uses the regular rules, and for this fixed date, you have this specific standard time, start and end date of this profile, and it will end on 23rd 59 minutes on the 26th December. Autoscale settings schema, weekdays and weekends. So you can then specify to be on weekdays and weekends. So let's say that on weekends you want your maximum capacity to be 4. On weekdays, because you expect more load, you want your maximum capacity to be 10. In this case, your settings would contain 2 recurrence profile, one to run on weekends and one to run on other weekdays. The JSON settings display here shows that each recurrence profile has a schedule. This schedule determines when the profile starts running. The profile stops when it's time to run another profile. For example, in this JSON displayed here, weekday profile is set to start on Monday 12 a.m. That means this profile starts running on Monday 12 a.m. It continues till Saturday 12 a.m. when weekend profile is scheduled to start running. So now we need to do a demo for this, but I would request you, or I would suggest you to do it yourself, because this is really easy one, but you will learn a lot. So what I want you to do, create an app service plan resource, define a new custom metrics using application insight, create a new autoscale rule in the app service plan using the custom metric as criteria. So what you need to do for the demo, create a app service plan resource, create a new custom metric using application insight, and create a new autoscale rule in the app service plan using the custom metric as criteria. So then you will have your full autoscale by custom metrics. Autoscale concepts. So a resource can have only one autoscale setting. An autoscale setting can have one or more profiles, and each profile can have one or more autoscale rule. An autoscale setting scales instances horizontally, which is moved out by increasing the instances in by decreasing the number of instances. An autoscale setting has a maximum, minimum, and default value of the instance that we saw already. An autoscale job always reads the associated metrics to scale by checking if it has crossed the configured threshold for scaling out or scaling in. All thresholds are and calculated at an instance level. For example, scale out by one instance when average CPU is greater than 80%, when instance count is 2. Means scale out when the average CPU across all instances is greater than 80. All autoscale failures are logged into the activity log. You can then configure an activity log alert so that you can be notified via email, SMS, or webhooks whenever there is an autoscale failure. Similarly, all successful skill actions are posted to an activity log. You can then configure an activity log alert so that you can be notified by email, SMS, or webhooks whenever there is a successful autoscale action. You can also configure email or webhook notifications to get notified for successful scale action via notification tab on the autoscale settings. So these are the main concepts about autoscale. Autoscale thresholds. With autoscale, you can add the right amount of resources to handle increased load on your application. It also helps you save money by removing idle resources. You specify a minimum or maximum number of instances to run, and the system will automatically add or remove virtual machines based on a set of rules. Having a minimum ensures that an application is always running even under no load. Having a maximum limits your total possible hourly cost. So you have here scale is constant to a minimum and maximum. So your current instance count must be between the minimum and maximum. Minimum can help guarantee availability, maximum can help control cost. So you see here you have minimum 2, and then you can increase or decrease by 1 until maximum 5. So currently, let's say you have 3 running, then you have a rule set. If that is to increase, it will increase 1 more. If that rule set defines that no, you need to decrease 1, then you can have minimum 2. If then the idle will be always default and minimum will be 2. So even if the next condition is to decrease 1 more, still it will be 2. Autoscale workflow. So resource emit metrics, and these metrics are later processed by rules. When autoscale rule conditions are met, one or more autoscale actions are triggered. You can add and remove virtual machines or perform other actions by using automation tools. So metrics are measured for a resource. When conditions are met, thresholds surpassed, autoscale triggers. So it performs skill actions, send notifications and messages to webhooks for external automations. Autoscale hierarchy. Autoscale uses these terminologies like the autoscale engine reads an autoscale setting to determine whether to scale up or down. It contains one or more profile or information about the target resource and notification settings. An autoscale profile is combination of a capacity setting, set of rules, and recurrence. So capacity setting, which indicates the minimum and maximum and default values for the number of instances. Set of rules, each of which includes a trigger, time or metric, and a scale action up or down. Recurrence, which indicates when autoscale should put this profile into effect. So you can have multiple profiles, which enables you to take care of different overlapping requirements. For example, you can have different autoscale profiles for different times of the day and days of the week. A notification setting defines when what notifications should occur when an autoscale event occurs based on satisfying the criteria of one of the autoscale settings profile. Autoscale can notify one or more email addresses or make calls to one or more webhooks. So this uh, this is the hierarchy. Best practices. So there are many best practices. Five of them are main, so I'm addressing them here. So first one is ensure that maximum and minimum values are different and have an adequate margin between them. So if you have setting that has minimum 2, maximum 2 and the current instance count is 2, then no scale action can occur. Keep an adequate margin between the maximum and minimum instance counts which are inclusive. So autoscale always scale between these two limits. Manual scaling is reset by autoscale min and max. So if you manually update the instance count to a value above or below the maximum, or the autoscale engine automatically scale back to the minimum if below, or the maximum if above. For example, you set range between 3 and 6, and if you have one running instance, the autoscale engine scales to 3 instances on its next run. Likewise, if you manually set the scale to 8 instances, on the next run scale it back to 6 instances. Manual scaling is temporarily unless you also reset the autoscale rule. So manual scaling is reset by autoscale min and max. Always use scale out and scale in rule combination that performs an increase and decrease. So if you use only one part of the combination, autoscale will take action in single direction, maybe scale out or scale in, until it reaches the maximum or minimum instance count defined in your profile. This is not optimal because you ideally want your resources to scale up at times of high usage to ensure availability, but similarly at the times of low usage you want your resources to scale down so that you can realize cost savings. Same way, choose the appropriate statistics for your diagnostic metrics and choose the threshold carefully for all metric types. So don't choose anything, but just think about it. Consideration for scaling threshold values for special metrics. Implement code that addresses the singleton instance. So in this lesson we will cover querying resources using Azure CLI, querying resources by using the Fluent Azure SDK. So Fluent is a library from Azure, and using that we can implement code that addresses singleton instances. So querying resources using Azure CLI. Azure Command Line Interface. Azure CLI is the Microsoft cross-platform command line experience for managing Azure resources. You can use it in your browser with Azure Cloud Shell, or install it in your Windows, Linux, macOS, and run it from command line. Azure CLI is optimized for managing and administering Azure resources from the command line, and for building automation scripts that work against the Azure Resource Manager. The CLI uses the query argument to execute a JME's path query on the result of command, and JMES path is a query language for JavaScript object notation JSON that gives you the ability to select and present data from Azure CLI output. These queries are executed on the JSON output before they perform any other display formatting. The query argument is supported by all commands in the Azure CLI. Then you have getting Azure virtual machines. So to get Azure virtual machines, you can use AZ VM list. Many CLI commands will return more than one value. These commands always return a JSON array instead of JSON document. Array can have their elements accessed to index but there is never an order guarantee from the Azure CLI to make the array easier to query. We can flatten them by using GME's path operator. In this example, if we use AZ-VM list command to query the list of VM instances, the query will return the large JSON object for each VM in the subscription. Then projecting virtual machine properties. So using the query argument, we can specify project-specific fields to make JSON object more useful and easier to read. This is useful if you are decreasing the JSON object to a specific type of code. So if you see AZ-VM list query, and then I say array.name image storage profile image reference.offer, so we only asking for image name and image reference offer. So that's how you can query. So if you want to query querying results set projecting properties, so you can using the array operator, this one, you can create queries that filter your results set by comparing the value of various JSON properties. So in this array operator, then you question mark starts with storage profile image reference dot offer, and which is with the value ubuntu, and the name and the ID is VM ID. Then you have only one because you filtered it with the ID, and the name is Linux VM, and the ID is this. Querying resources by using Fluent Azure SDK. This is in manner similar to how you use Azure CLI. You can use Azure SDK to query resources in your subscription. The SDK may be better option if you intend to find connection information for a specific application instance. For example, you might need to write code to get an IP address of a specific VM in your subscription. So newest Azure SDK for .NET support Fluent queries. Fluent methods can be chained together to create easy to read queries. Prior to using Fluent SDK, you had to create an authorization file that contains metadata about the service principal. The authorization file is used to authenticate the SDK. You will authenticate, and then you use this authenticated file every time you do some action with the Fluent SDK. Creating authorization file by using Azure CLI. In this file, you have AZ-AD-SP create RBAC SDK auth azure.auth. Then you need to provide client ID, client secret, subscription, tenant ID, blah blah, all those things. Authentication by using Azure, authentication by using Fluent SDK. To use API in the Azure Management Library for Microsoft.NET, as a first step, you need to create an authenticated client. The Azure SDK requires that you invoke the Azure.authenticate static method to return an object that can fluently query resources and access their metadata. The authenticate method requires a parameter that specifies an authorization file. So here you just say Azure, which is coming from the Fluent API. Fluent library, Azure.authenticate, Azure.auth with default subscription, which we defined here, this file, and it will use this file and authenticate you. Then listing virtual machines by using Fluent API. After you have variable of type iAzure, you can access various resources by using properties of the iAzure interface. For example, you can access VMs by using the virtual machines property and link expression. The properties have both synchronous and asynchronous versions of the method to perform actions such as create, delete, and list and get. If we wanted to get a list of VMs and asynchronously, we could use list async method. So here you see VMs equals to await azure.virtualmachines i.list async. Here we have the Azure variable from the authentication. So once we authenticate the default subscription, or you can specify the subscription, now you have Azure instance, and Azure instance you can perform actions on that. Listing virtual machines by using the Fluent Azure SDK. Same way, once you have all VMs, list async Azure virtual machines, then you can select the target VM by using the link queries with the VM name, simple, blah blah, all that, and then you have target VM now, and access virtual machine metadata by using the Fluent Azure SDK. Then you can target NIC, network interface provider, and target VM.get primary network interface. So the target VM, we got it from here by filtering using the link query, and using this target VM we can get more information from that. So INICP configuration, target IP configuration, target NIC. So first we got the target NIC, and from the target NIC we can get the primary IP configuration, and then from the target IP config, which we got here, then we can get the public IP address. So you see, we go one by one. Further, implement code that handles transient faults. So in this lesson we will cover transient errors, handling transient errors in code, detecting if an error is transient. So transient errors. An application that communicates with elements running on the cloud has to be sensitive to the transient errors that can occur in this environment. Faults include the momentary loss of network connectivity to components and services, the temporary unavailability of a service, or timeouts that occur when a service is busy. These faults are typically self-correcting, and the action that triggered a fault is repeated after a suitable delay. It's likely to be successful. For example, a database service that's processing a large number of concurrent requests can implement a throttling strategy that temporarily rejects any further request until its workload has eased. An application trying to access the database might fail to connect, but if it tries again after a delay, it might succeed. So temporarily down. Handling transient errors. In the cloud, transient faults aren't uncommon, and an application should be designed to handle them elegantly and transparently. This minimizes the effects faults can have on the business tasks that the application is performing. If an application detects a failure when it tries to send a request to a remote service, it can handle the failure by using three strategies displayed here. For the more common transient failures, the period between retries should be chosen to spread requests from multiple instances of the application as evenly as possible. This reduces chances of busy service continuing to be overloaded. If many instances of an application are continually overwhelming a service with retry requests, it will take the service longer to recover. If the request still fails, the application can wait and make another attempt if necessary. This process can be repeated with increasing delays between retry attempts until some maximum number of requests have been attempted. The delay can be increased incrementally and exponentially depending on the type of failure and the probability that it will be corrected during this time. So you have cancel, retry, and retry after a delay. So you can keep increasing that delay. Retrying after transient error. So this diagram will illustrate invoking an operation hosted service using the retry pattern described in the slide. If the request is unsuccessful after a predefined number of attempts, the application should treat the fault as an exception and handle it accordingly. So you try, you get 500, you can try, you get 500, you can try, then you might get 200, Handling transient error in code. So you have retry count 3, read only time span delay. You can put any delay, and then the current retry is 0, and then you start try, await, transient operation, async, break, catch exception, try, trace error. You put some, you handle that exception. If current retry plus plus this is greater than retry count, which we defined here, then we throw error, else we await task delay and do it again. You see, so this is this for loop. You see, there is no condition, no increment, nothing. The conditions and increments are here, and you can throw an exception after certain retries, detecting if an error is transient. If example, if x is exception is operation transient exception, then return true. Where exception as web exception, return. So we can check if operation transient exception. So review. To review, in this video we talked about implementing auto-scaling, implement code that addresses singleton instances, implement code that handles transient faults. I hope you remember what we talked about, and I talked about a demo which you should do yourself to do some auto-scaling and configure it according to your rules. You need to create some resources for that, and then you can define some rules depending on the insights on the metrics. So I hope you like this video, and thank you for watching. Please like, share and subscribe this video, because this will increase the ranking of this video, and then I will be happy. YouTube will put my video on suggestions. So if you liked it, thank you for liking, sharing and subscribing.